Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is matrices. What you are going to learn today is matrix multiplication. So let's begin. After completing the very lesson today, my dear student, will be able to find the product of two matrices. That is, we'll be able to perform multiplication of two matrices. This is what I hope you'll be able to do after completing the very lesson today. As usual, my dear student, your favorite segment of the lesson. Today, I'm happy to give you another special group of numbers. And this special group of numbers, they are called reversible symmetric numbers. We have seen in one of our previous lessons what is a symmetric number. So we're going to take another group that is called reversible symmetric number. I'll explain this group of numbers after completing my lesson today. So don't go away. My dear student, to begin the lesson, let us first learn the rule. It is this rule that will guide us what to do in attempt to do multiplication of two matrices correctly. So let's take the rule. It says to multiply the two matrices. That is, this is conditions before even you attempt to start multiplying the two matrices. You have to take note of this condition. It says the number of columns of your first matrix must be equals to number of rows of the second matrix. Otherwise, you cannot multiply the two. If you check the condition and it is true, then you can start to multiply. And how you multiply, this is how you multiply. We now said after you multiply, of course, you have another new matrix, and that new matrix will now have entries, and those entries in your resulting matrix will now be products of rows of the first matrix by the columns of the second matrix, which means you now multiply rows of the first matrix by the column of the second matrix. That will give you the resulting matrix, which will now serve as the product of the two matrices. We are going to take examples how we can make use of these two guidelines and find the product of the two matrices. So let's just move and take examples. So example number one, it says given that matrix A. This is matrix A with this entries 1, 3, and minus 4 in the first row, and it is only having one row. And this is matrix B with the entries to 2, 3 in the first row, minus 1 in the minus 1 and 0 in the second row, and another matrix C, which is a 3 by 3 matrix 2, minus 1, 5 in the first row, 2, 3, 4 in the second row, 0, minus 2, and 1 in the third row. These are three matrices given. And what the question says, which of this following multiplication could be possible? So you have one, A times B. We have to check whether it's possible or not. Number two, B times A. We have to check whether it's possible or not. Number three, A times C. And number four, C times A. So we have to find out whether these multiplications could be possible. We are not asked to do the multiplication yet, but just to check the conditions, whether this four multiplication could all happen. So solution to this very problem. So what we simply do to find the answer to this, we now remember that very condition. The condition says to multiply two matrices, the columns of the first, that's the number of columns of the very first matrix must be equals to the number of rows in the second matrix. So if multiplication of A and the B, A will now be your first matrix and the B will now be your second matrix. So if we go back to this matrix A, how many columns it has? Check the number of columns of the first matrix. It has 3 columns. The condition says number of columns of first must be equal to number of rows of the second matrix. So you now count how many columns in the first matrix. In this case, it is 3 columns, 1, 2, 3. That is matrix A. And B is your second matrix. And this matrix B has how many rows? 1, 2. This one has 3 columns, but this one has 2 rows. And the condition says number of columns first must be equal to number of rows of second. So in this case, the number of columns of first is not the same as the number of rows in the second. So 3 is not equal to 2. Hence, we cannot do this multiplication. So this multiplication is not possible. We move to the second one. Let's find out whether If A times B is not possible, could the B times A be possible? B times A, so in this case, B is your first matrix, while A is your second matrix. So number of columns of B, that is your first matrix, is 2. And the number of rows of A is 1. And in that case, 2 is not equals to 1. Hence, it is not possible, this one also. So I move to number 3. Number 3, we have to perform the A times C, A and the C. So matrix A has 3 columns, 1, 2. A is your first matrix, and this time around C is your second matrix. This is matrix C. How many rows it has? 1, 2, 3. So the number of columns of the first matrix A and the number of rows in the second matrix C are the same, 3, 3 each, which means this multiplication could be possible. So this is now possible. And moving to the last one, number 4, we have to perform the C times A. So matrix C has 3 columns, 1, 2, 3. And the matrix A has 1 row only, and 3 is not equals to 1, then you cannot do this multiplication, hence it is not possible. This is how we answer this very question. It's just trying to test us the conditions of the multiplication of the two matrices. So let's just take another example where we can really do the multiplication. So we have matrix A as given here and matrix B given here, and asked to compute the product of A and B. Solution to this very problem. So copying the given text, that is matrix A times B. A is your now first matrix and B is your second matrix. And we now check the condition. Number of columns of first. Number of columns of first matrix A has 1, 2 columns. Then the number of rows in B. B has 1, 2 rows. So the numbers, columns first equals the number of rows in the second. Hence, we can do this multiplication. So let me just copy down the two matrices. That is matrix A times matrix B. And the next, the rule tells us that we now multiply row by column. So row of the first times the column of the second. So I'm going to have my multiplication like this. Let me just open very large one so that I can now write the real multiplication before I compute those products. So I'm going to have this row times this very column. Let me do that. Look at it. This row times this column is what I'm going to have here. So I'm going to have 1 times 4 plus 5 times minus. So I'm going to add the two products. 1 times 4, the result plus 5 times minus 1. Let me just write it here. So 1 times 4 plus 5 times minus 1. So I'll move. Next, I'm going to take this row times this column. This row times this column. Let me do that. So look, let's see it. First row times second column. It will give you the entry here. So you now have 1 times 2 plus 5 times 3. That is 1 times this 2 plus 5 times this 3. Then to write the element here, you now take first row times third column. Let me do that. First row times third column. So you now have 1 times 1 plus 5 times 5. That will give this answer 1 times 1 plus 5 times 5. I'll continue. So I will now take the second row. The second row of your first matrix. The second row of your first matrix times the first column, of your second matrix. So let me have this second row times the first column. So I'm going to have the element here now. So it will now be 3 times 4 plus 2 times minus 1. Let me write it. So 3 times 4 plus 2 times minus 1. Then to get the element over here, that is second row, second column, you now take second row times the second column. So you now have 3 times 2 and 2 times this 3. So you now have 3 times 2 plus 2 times 3. This is what we shall be doing. So this will now be the 3 times 1 plus 2 times 5. This is what I'm going to have. Then you move to the last row. Last row will now have meaning to write the element here, we'll now take this third row and all the 3 columns here. So you're going to have minus 2 times 4 plus 0 times minus 1. And the next one is now going to be that row times this column. So you now have minus 2 times 2 plus 0 times 3. And lastly, third row times third column, that gives you minus 2 times 1 plus 0 times 5. So what I'm going to do is to multiply and add so that I'll have my resulting matrix. So let me do that. So my resulting matrix, if I should find this answer, 1 times 4 is 4. 5 times minus 1 is minus 5. So I'm going to have 4 minus 5. That give answer minus 1. Look at it here. Then I'm going to take the next one. Next one is 1 times 2 plus 5 times 3. 5 times 3 is 15 plus 1 times 2 is 2, which is 2 plus 15. That will give me answer 17. Look at it here. Then next 1 times 1 is 1 plus 5 times 5, 25. So I'm going to have 26 over here. Look at it. I'll continue like that. I'll keep multiplying and adding and now write the result. If this is done correctly, you have 10. And this, if done correctly, that gives you answer 12. If is done correctly, that will give answer 13. If this is done correctly also, that will give you answer minus 8. And if this is done correctly, that will give you result minus 4. If this also is done correctly, that will give you result minus 2. So this is the product of these two matrices, A and B. That is A times B, which of course may not be the case exactly the same result. B times A may not even be possible. We don't know. So let's just move and take one more example. So example number 3 says, given that this matrix with the entries 1 and x in the first row, y and 4 in the second row, and times another matrix with 5 in the first row, minus 2 in the second row. The result of multiplying these two matrices give another matrix with the 3 in the first row and the 2 in the second row. The question asked is to find the entry x and the entry y. Solution to this very problem, we copy the given equation, that is equation involving this matrices. What we now do, remember, the rule of multiplication says we multiply row by column. So multiplication of this first row by this column is what gives this 3. There I can now form the simple equation that I can get to my x here as the unknown. Similarly, multiplication of this second row by this column is what gives this number 2 in the product. So I can also use that to form simple equation that I can solve for y. So let me just do that. So I now have 1 and x, that is element in this very first row, times this column is what gives me this very 3. So I have 1 times 5 plus x times minus 2 is what gives me this very 3. So after that, I will now have a simple equation that is 5 minus 2x equals to 3. 5 minus 2x equals to 3. So I can now solve for x here. I'll take that 5 to the right hand side. There gives me minus 2x equals to 3 minus 5. And 3 minus 5 gives answer minus 2. There you now have minus 2 equals to minus 2x equals to minus 2. And dividing both sides by the coefficient of x, which is minus 2, will now give you x as a positive 1. So you can now see I have obtained the value of this very x. So I'll move and get to y. So this is my entry y here. This row times to this column is what gives you this answer 2. Let me just show you. That is y and 4, the element in this row, times the elements in this column is what gives you this entry 2. So I can now use this to form simple equations in terms of y, which I can solve for y. So y times 5 is now 5y plus 4 times minus the 2, which will be minus 8. So you now have 5y minus 8 equals to this number 2, which you can now solve for y. So this minus 8 taken to the right hand side, you now have 5y equals to 2 plus 8. 2 plus 8 gives you 10, and you now divide both sides by 5 to get y, and that, if that is done correctly, you now have y equals to 2. So you now have value of x to be 1 and the value of y to be equals to 2, and that answered this very question. So with these few examples, I hope you, my dear student, will be able to perform multiplication of two matrices. This is the end of this very lesson. Thank you for your attention. Let me just move to the last segment and explain the special group of numbers called reversible symmetric numbers. So let me explain, my dear student, what are reversible symmetric numbers. So symmetric numbers whose reversal is another symmetric number are called reversible symmetric numbers. So all reversible symmetric numbers are indeed symmetric, but it is those that also their reverse is another symmetric number. It is those that we call the reversible symmetric number. So let's just take examples of reversible symmetric number. One of them is 58. So 58 is symmetric, and it is indeed a reversible symmetric. But let me explain the term symmetric here. 58 is symmetric because if you now factor this 58 as 2 multiplied by 29, the digit sum in the factors and the digit sum in the number itself will now be the same. Let's just find out and see. So this is 2. 29, if I add it is digit, I'll have 2 plus bracket 2 plus 9. So addition of these three numbers, 2, this very 2. And this bracket is 2 plus this 9. That is one of the factors, digits in one of the factors of 58. So this result is going to give me 13. If I go back to the same number, 58, add it is digit 5 and 8, it's going to give me this 13. So sum of digits in 58 is also 5 plus 8. It is also going to be 13. So that's what makes a 58 symmetric number. I have explained this in one of my previous lessons. But 58 is a reversible symmetric because it is reversal. That is 85. 85 is another symmetric number. Let me just take, this is 85, reverse of 58. Let me check whether this is symmetric. So factors of 85 is now 5 times 17. And if I add those digits in 5 and 17, I'll now have 5 plus 1 plus 7. This will give me 13. And the sum of the digits in 85 also, that is 8 plus 5 is another 13. So you can see 58 is symmetric and it is reverse. 85 is another symmetric number. So which means 58 is a reversible symmetric number. You can equally say 85 also is a reversible symmetric number because it is reversible will now be 58. We see more of these interesting things in mathematics in our subsequent lesson. Thank you for your attention.